Hello everyone, so let's start with today's session. So let's solve this problem. Please read the problem carefully and after that answer this. Okay, so let's read the question properly. Which of the following statements about thread are true? First, A is threads can only be implemented in kernel space. Each thread has its own file descriptor table for open files. All threads belonging to a process share a common stack. Threads belonging to a process are by default not protected from each other. So, if we see the option 1, so option A, this is false. Why? Because as we can implement threads in user space with the help of kernel. Okay, with the help of kernel threads. So this is not the correct option. After that, if we talk about second, so a process block has a single file descriptor. All threads belonging to the process share the same descriptor along with the data segment, heap and code. Okay everyone, so this is also false. After that, all the threads are shared among memory address space, but not the same stack. We augment multiple stacks in the same address space belonging to a process for each of the threads. This allows for parallel execution of the thread. Alright, so this is also not the correct one. After that, if we see option last, so since all the threads belong to the same process, which results in obtained by one thread, okay, which might be used by another thread to continue with the execution, which is critical section problem. That is why definition user kernel thread are not protected from one another, and the job of maintaining protection is left to the developer. So this is absolutely correct statement. So that is why here D option is correct. Now please see this everyone and try to answer what is the correct answer for this particular question. So which of the following process state transactions is not possible? So which is not possible? Not possible, you should highlight this. Okay. So let's see the first one. Running to ready. Running to ready is possible. Okay, a process can go from running to ready, right? So this is which is possible. Waiting to running. Okay, so this is not possible. Waiting to ready it goes, not running. That is why this is wrong. So B is correct because we want not possible. After that, ready to waiting. So can it go from ready to waiting? Absolutely not. So that is why this is also correct. Running to terminated. Yes, a process can go from running to terminated, right? So that is why D is correct, but we want not possible. So B and C are the correct answer. Okay. So I will draw a short diagram to let you know how things work. So this is new process. Here the process waits. After that, the process is admitted. Okay. To ready. Then here is the running. And here is the waiting. And here is terminated. Okay. So this is called as exist. And this is interrupt. Okay, this transaction is about scheduler dispatcher or dispatch, let's say. After that, this transaction goes from IO or event completion. Here to here, this goes from IO or event wait. Right, everyone? So can you see the transaction anywhere from waiting to running? No. Ready to waiting? No. Okay. So, but we can see the transaction from running to ready. Yes. We can see the transaction from running to terminated. This is also correct. So that is why B and C are the option, not A and D. So let's move to next question. Solve this question, everyone. I am enlarging the image. Try to solve this, giving a minute time. Done with this? Yeah. Now, which of the following is our bottom-up parser? So, shift reduce parser, predictive parser, LL1 parser, LR parser. So, the purpose of taking all these questions is to revise the concepts which are used for solving this question. That is why we are taking the PYQs of 2024. Alright. So, let's revise the concept behind that. So, here are the parsers. They are classified as top-down parser, which is also called as TDP. After that, it is also classified as bottom-up parser, which is called as BUP or SR parser. Okay, everyone. Then this TDP is further classified like this, which is TDP with full backtracking. Okay, and here is TDP without backtracking. After that, here is operator precedence parser, and this is LR parser. After that, from here, this will go to recursive descent, and from here, this will go to non-recursive descent, which is LL1. Alright, everyone. After that, here LR parser will be bifurcated as LR0 parser. After that, SLR1, SLR1. After that, this will go as CLR1, and this will go as LALR1. Alright, so like this the bifurcation will be there. Now can you answer? So from the above classification of parser, it is very clear that LRK and shift reduce parsers are the types of bottom up parser. Okay, with LL1 and recursive descent parser belongs to top down parser. So which is the correct one? Bottom up parser are shift reduce parser. Okay, and D is correct, LR parser. Okay, after that predictive parser and LL1 belongs to top down. Any doubt here in this? I hope that there is no doubt. Let's move to next question. Solve this question, everyone. I'm giving a minute time. Okay. So let A and B be two events in a probability space with probability of A equals to 0.3, probability of B equals to 0.5, and probability of A intersection B is 0.1. So which of the following statements are true? The two events A and B are independent. How we will say that they are independent? When probability of A intersection B is equals to probability of A into probability of B. So A intersection B is 0.1. So probability of A is 0.3 into 0.5. So this is clearly not equals, okay, because this is 0.15 and this is 0.1. So we can say that they are not independent. So this is definitely not the answer. Now they are saying that probability of A union B is 0.7. So what is the formula for the union? So it is nothing but probability of A plus probability of B minus probability of A intersection B. So which is 0.3 plus 0.5 minus 0.1, which is coming out to be 0.7. So this is exactly same. That is why B is the correct answer. Then let's talk about option C. So A intersection B bar is equals to 0.2, where B is the complement of the B event. Okay, this B to the power C is the complement of the B event. So that is the representation. Now how we can write this? So this can be written as probability of A minus B. Okay, probability of A minus B. This particular thing can be written like this. So which means P probability of only A. So what is the probability of only A? So here this is 0.3 and this is 0.1. So we can subtract 0.3 minus 0.3, or we can do like this. So for only A, see, if these are the two diagrams. Here is 0.1. Let me draw it properly. You can easily get from this Venn diagram. If this is 0.1 and they are saying that the complete A is 0.3, but this space is already covered, so it will be 0.2. And if this complete B is 0.5, but this is already covered, so this is 0.4. And they are saying that only A I want. So clearly it is 0.2. So the answer will be 0.2, which is absolutely correct. So C option is also correct. Understood everyone how to write if you don't know the formula? After that, this is A complement intersection B complement equals to 4, where A to the power C and B to the power C are the complements of the event A and B respectively. So this can be written as probability of A union B complement, and this can be written as 1 minus probability of A union B, and A union B we have already calculated from here, which is 0.7. So here what will be the answer it should give? The answer is 0.3. But here they are saying the answer is 0.4, which is absolutely wrong. That is why D is also incorrect. So they are asking for the true statements. So B and C are the only options which are correct. So B and C are the correct one. So I hope you how to solve this question. Let's see the next one. Solve this everyone. Read this once. Okay. So waiting few more minutes. Okay, so let's read this question. Consider the circuit shown below where the gates may have propagation delays. Assume that all the signal transaction occurs simultaneously or instantaneously and the wires have no delay. Which of the following statement about the circuit is are correct? The circuit is shown below, wire has no delay, okay? Gates may have propagation delay, right? So let's see this. So there are two cases which can be derived from this. So we will discuss case 1. Case 1 is when there is no propagation delay. This circuit is simple combinational circuit, and what is the equation we are going to get? So y we are going to get is x into x naught. So this is clearly 0. So why we are going to get 0, which is a false logic, right? That is what we are going to get when no delay is there. So this is our case 1 for no delay condition. Okay, so with no propagation delay, the output of y is always logic 0. So this is correct. With no propagation delay, the output y logic 1. So clearly this is false. So B is not correct. Now with propagation delays, so the statement with propagation delays are given to you. Let's see now how we can solve this. So this is the case 2, let's solve. So if you consider the delay in the NOT gate, okay, when the signal x transitions from 0 to 1. So this, let's suppose this is from 0 to 1, it is transacting, and if the delay of AND gate is larger then the NOT gate momentarily, and the NOT gate will be outputting the older, which is the incorrect signal. So because of this we will get a transit, okay, which is called temporary. So the logical 1 output from the circuit will be there. Alright everyone, with the delay, this will be the case. So initially let's say y is 0, okay, y is 0 coming, x is 0. So this is what let's understand. So what they are saying, let's verify option C and D. So with the propagation delay, the output y have a transit logic 1 after x transition logic from 0 to logic 1. Okay, so 0 to 1. So that's why we are considering y is equals to 0, x is equals to 0, alright, and x bar will be definitely 1. So the transit here from x will be 0 to 1, right? And considering delay, we are considering delay in NOT gate. So now if we take x equals to 1 and x bar 1, as we consider delay in the NOT gate, that is why. So here y will be x into x bar, which is 1. Okay, so after the delay, this will be the case. So that is why C here is correct, but not D. If C is the correct, then automatically D is wrong. Okay everyone, any doubt here in this question? Okay, so let's move to the next question. So read this question properly. Done reading? Let's see. TCP client P successfully establish a condition to TCP server Q. Let NP denote the sequence number in the sync sent from P to Q. Let NQ denote the acknowledgement number in the sync acknowledgement Q to P. Which of the following statements are correct? So, TCP always starts connection with an initial sequence number that is randomly generated in the range of available sequence number. So to avoid this conflict with delayed packets from the previous session, this is a safety measure to reduce the probability of accepting delay packets from a past close connection to be accepted by a new connected made from the same host and same port. So TCP acknowledgement always sends the next expected byte sequence number. That is why NP plus 1 will be sent as the acknowledgement number. So NP plus 1 will be sent. Okay, and A is the correct. So the sequence number NP is chosen randomly by P. Okay, because it is randomly generated in the range of available sequence number. So that is why A and D are correct. Okay, so A and D are absolutely correct here. Okay, see this question, everyone. So try to solve this. So take your time and read the question properly. Let's read. Consider 5-stage pipeline processor with the instruction fetch, instruction decode, execute, memory access, register write back stages. Which of the following statements about forwarding are correct? So we have to analyze each statement about forwarding in the context of pipelining processor with the stage givens IF, which is instruction fetch, instruction decode, execute, memory access. After that, register write back. So first, in the pipeline execution, forwarding means the result of a source stage of earlier instruction is passed on to the destination of the later instruction. So this statement is correct because forwarding, also known as bypassing, which is a technique used to reduce data hazards by passing the result on instruction directly to subsequent instruction that needs it without waiting the result to be written back to the register file. So this is absolutely correct. After that, the second. So in forwarding, data from the output to memory access stage can be passed to the input of the execute stage of the next instruction. This is also correct because one common form of forwarding involves passing the output from memory stage where the results of a rollback load instructions might be available directly to the execute stage of the next instruction that needs it. That is why this is also correct. Now forwarding cannot prevent all pipeline stacks stalls. So this is also correct because forwarding helps mitigate certain types of data hazards, particularly read after write hazards, but it cannot eliminate all types of pipeline stalls. So for example, hazards arising from control dependency, branch instructions, or certain instructional hazards might cause stalls. So that is why this is also correct. So the last one here is forwarding does not require any extra hardware to retrieve the data from the pipelining stage. This is incorrect because forwarding requires additional hardware such as multiplexer and control logic to select the appropriate data to be forwarded and to ensure that the data is correctly routed to the required pipelining stages. So that is why D is not the correct one. So here the answer corrects are A, B and C. So I hope you got this. Let's see the next question. So read the question very properly and try to answer this. Done everyone? Reading? Okay, so let's read this question. Which of the following fields is are modified in the IP header of a packet going out of network address translation NAT device from an internal network to external network? So NAT devices take the outgoing packet and replace the source IP address from private address pool to IP address from its public address pool. And since the source IP address is changed, the header checksum is also recalculated so that the router does not get error while checking the header checksum. So that is why here A and C are the correct answer. Okay. I hope there is no doubt in this. Now see this question everyone. So try to answer this. Okay, done with this. Okay, let's see this question. Let A and B be non-empty finite, not infinite, finite sets such that there exists one-to-one and onto functions. First is from A to B. Second is from A cross A to A union B. The possible number of values of A is. So first they are saying that there exists one-to-one and onto functions between X implies Y. So what that means? See this? There exists one-to-one and onto function between x to y, x and y implies x equals to y. Okay, so that is why here we can say that from this particular property we can say that a is equals to b. Okay, and here this is a square, so a square is equals to this one, which is a plus b minus a intersection b. Okay, so this is possible, everyone. Now if you will put all the values here, what are you going to get? So if you just try to put here a value as 1, so are you going to get the value? So just see here, a equals to 1 if I put here. After that, so a plus 1 minus, here is also the same. So same we are going to get. But if we put 2, then what will be the answer we are going to get? If we put a equals to 2, then what is the answer we are going to get? So a value, first condition is a equals to 1. So here it will be 1. Here it will be 1 plus 1 minus a intersection b, like this. So here 2. Okay, so a intersection b value is also getting 1. After that, let's try to put a value as 2. A value as 2. Let's try to put this. So here will be 4. After that, 2 plus 2 minus this particular value, let's say x, or let's say w, this is, I am representing this one. So this will be 4 minus 4. Okay, minus, so this will comes out to be 0. So intersection will be 0, right? And for the, so intersection will be 0. Alright, everyone. So they are saying how many number of values possible for this. Then if we try to take a equals to 3. So 3, 9 here will be, 3 plus 3 here will be, and after that this will be w. So this will be 3. So w equals to minus 3, like this will be there. So for the larger value, what will happen? A and a square will be greater than a plus b. So that is why only the possible values are just 2. Okay, just 2 values are possible. So this is one more way, and the other way from which we can get this question is, so this was the method 1. Those who have understood this is okay. Rest they can concentrate here if you haven't understood this. Okay, so let's suppose a equals to n, and here this is also called as 1 to 1 and on to is also called as bisection. So because of that, if a is n, b is also n. And here they have said that a into a, so this will be n square, right? And there exists a bisection between a into a and a union a, so that is why this also will be n square. Now you have to consider general principle that the cardinality of the union of two sets is at most the sum of cardinalities of the individual set. So you know all this property, a union b is always smaller than equals to a plus b. So this is a standard one which you should remember. So as we know that a is n, b is n, okay, so n and n, so this will be smaller than equals to n plus n, which is smaller than equals to 2n. Okay, and now if we put the value of a union b, so this is n square, like that. So n square minus 2n smaller than equals to 0. So n n minus 2 smaller than equals to 0. So n value is clearly 0. Okay. And the second value will be, which will be 2. So for to be non-positive, where this n belongs to 0 and 2, like this. But n cannot be 0. Why? Because they have said that non-empty. Non-empty. So that is why either n can be 1 or n can be 2. Right? The number of possible values. So what are we saying? What we will say the number of possible values? Only 2 values are possible, 1 and 2. So that is why 2 is correct. So those who haven't got the first method, they can solve by this second method. But because of the first method, you got to know why I have written A value also n, B value also n. And from here also we have calculated the A union value and this value. So the property you should know for this. Alright everyone? Solve this question everyone. At least read the question and we will try. Okay, let's solve this question. But this question will require more space, so that's why I'm writing. So you all have read this question properly, right? So now if I will write something, so you will get it. So what is the expression we have? 3 plus 1 plus 5 into 2 by 7 plus 2 minus 4 minus 7 minus 6 by 2. Okay. So as plus has higher precedence with the with left associative in the operators table, as you can see that plus has highest with the left associative. So so plus plus only we are going to solve first. So if we will solve this, so the answer of this will come 4. Okay, 4, and after that this 4 and this will sum up to 9. Alright everyone. After that this and this will give us the result 9, right? But this 9 into 2 by this will be 9, right everyone? This will be 9 plus 2. No, not plus 2 because plus 2 is already used. Minus 4 minus 7 minus 6 by 2, like this. Now which has the highest priority after that minus? Okay, which is from right. So right we have to use. So this is what. So what is the answer you are going to get from here? Everyone. So 1, because 7 minus 6 is 1, minus 4 minus 9, like this. And now next is this you have to solve. So this all will be as it is. So what is the answer? Minus 3, 9 minus 3 you are going to get, and rest will be as it is. Again you have to solve the subtraction one. So this will be 6, this 2, this 2, 9 like this. After that, what has the highest precedence? Multiplication, which is from right. So multiplication, this you have to solve. So this will give us 18 as the answer. 6, 2. After that, division has low. It is from right. So from here you have to solve the division first. So this will give you the result as 3. After that, this 3 and this 18 will give you the result as 6. Okay. So which is the correct answer? 6 is the correct answer. So here you have to write 6 is the answer. Let's see the next one. Okay, solve this everyone. Read the question properly and try to solve. So this is by direct formula question. Try to apply your logic here. Okay, let's see this question. The number of spanning tree in a complete graph of 4 vertex labeled A, B, C and D is. The direct formula is here, number of spanning trees in any complete graph, which is Kn, is n to the power n minus 2, where n is a number of vertex, like this. And in our case, n is given as 4. So in our case, n is 4. So the number of spanning tree is 4, 4 to the power 2, so which is 4 to the power 2 is 16. So the correct answer here is 16. Alright everyone, let's see the next question. Solve this question. It's a DBMS question. I'm giving a minute time. Okay everyone, try to solve this. Consider the following two relations RAB, SAC. The total number of tuples obtained by evaluating of the following expression. These are the expressions given to you. RA and SA. When they both are equal, we have to apply this condition. So let's see what is the table we are going to get. So this 10 and this 10 is equal. Yes. So we have to check B and C directly. So B is smaller than C. Right everyone? One tuple we got. Yeah. Now let's move to the next one. 20. Here is any 20? No. We will skip. This is 30. This is 30. Right? So let's check B and C. So B should be smaller than C. Yes, we are getting. So second tuple added. After that, again this 30 and this 50. So is this 50 smaller than 45? No everyone. So we are not going to add the tuple. After that, is there any 50 here? No, right? Again here, if we check this table, so 10 and 30 we did. No 40 is there. No comparison will be there. So how many tuples are we going to get? Just 2 tuples. So the answer is 2. So without even drawing the table, simply by looking at this, you can solve the question. Right everyone? Let's see now the next question. So it's a big question. Read properly and then we will discuss the solution for this. So big questions come from computer networks only. Alright. I'm waiting a minute. I'm waiting for a minute. After that, we will see this question. Okay, let's solve this question. Let's first read. Consider a network path PQR between nodes P and R via route Q. Okay, node P sends a file of size 10 to the power 6 bytes to R via this path by splitting the file into chunks of 10 to the power 3 bytes each. Node P sends these chunks one after the another without any wait time between the successive chunks transmission. Assume that the size of extra headers added to this chunk is negligible, okay, and that the chunk size is less than MTU, okay. Each of the link P to Q and Q to R has a bandwidth of 10 to the power 6 bits per second, negligible propagation latency. Router Q immediately transmits every packet it receives from P to R without negligible processing and queuing delays. So router Q can simultaneously receive on the links P to Q and transmit on link Q to R. We have to assume the P start transmitting the chunks at t to the power 0. Which of the following options gives the time in seconds and in the decimal up to 3 decimal places we want at which R receives all the chunk of the file. So basically we have to calculate the time. Okay, but first we have to get to know the number of packets that P can send. So how we will get number of packets that P sends, which is total size of packet by by splitting the chunks. So 10 to the power 3 bytes. So which means 1000 packets are there total which we have to send. So giving the propagation we have given that propagation delay is negligible and no queuing delay is there. Okay, and P2Q and Q2R, the bandwidth is given as this. Okay, now to solve this question, see, transmit all packets plus focus on the last packet's journey. Okay, so 1000 packet we will send. After that, propagation time, so like this, like this. So understand now. So this is for at P it will be. After that, this is for P to Q will be. After that, this is at Q will be, and this will be at Q to R it will be. Okay, so TP is given as 0, negligible. So directly 1000 time plus like this it will be needed. Okay, so which will be 1001 propagation okay, transmission time, and transmission time is nothing but length by bandwidth. Okay, length by bandwidth. And what is this given as? 1001. Length is given as 1000 into 8 bits, and length is given as bandwidth is given as 2 to the power 6 bits per second. Okay, and if you just solve this, so this will give us the answer 8.008 seconds, because bits and bits will get cancelled. Okay everyone, so this is the answer we are going to get. So total transmission time, number of packets plus n into, so this is how we have to write. Okay, so what is the answer? Correct answer everyone? It is B. And they are asking for 3 decimal places. So we have also calculated in 3 decimal places only. Okay, see this question everyone. So try to solve this question everyone. Okay, so try to solve this everyone. This question. Okay, so the symbol indicates functional dependency in the context of relational database. Which of the following is are true? So this is the implication. So xy implies zw. So this is possible that from the left hand side we can delete any of the attributes. Not correct. So that is why A is not correct. After that, xy can derive z and can derive w. Okay, this is possible. That is why B is correct. After that, xy deriving z and w deriving y. So this implies, so in place of y, we can replace it with w. So here y is replaced with w and it is deriving z. This is also possible by applying augmentation rule. And after that, x deriving y and y deriving z. So x deriving z. So this is nothing but transitivity, everyone. So that is why this is also correct. So BCD is the correct answer. Anyone having any doubt in this? So the first one is wrong because we cannot cut the attribute from the left hand side. We cannot decompose the attribute from the left hand side. This is important. We can decompose it from the right hand side, but it is not possible to decompose from the left hand side itself. And after that, B and C are the rules which we have seen already. Okay. So see you all in the next session. Thank you so much, everyone.